Hello, everyone. Can you hear me well? Okay, cool. So, a small intro. I'm Mohamed Rashad. You can call me Rashad. I'm from Egypt. I've been living in Yerevan for the past 2 years, and I've been building software for the past 11 years. Since 2017, I got more interested in AI because I have an interest in mathematics, and for the past 4 years, I've been working as a consultant slash fractional CTO for a number of companies, building AI systems. And I've built some systems for different companies from like one-person startups up to big corporates, noticeably Nokia, one of them. And this is my second time in PyData. The first time was in Dubai, and I'm happy to be here again. And I'll start, actually we will surround everything around a small hot take, which is building AI agents is not a software, not an AI problem, it's actually a software engineering problem. So if you want to prototype an AI agent, it's an AI problem, you have to deal with it. But once you want to take this to production, you want to serve it to users, it turns into a software problem or a software engineering problem. What I mean also by an AI problem is anything that's scientific, like dealing with the equations and prompts and tools and so on, not the back-end, front-end, DevOps part of things. So one thing that we don't have an agreement on is what is an agent. Even today, you'll find many articles, many people, LinkedIn influencers, everyone's telling something as an agent. So an agent ranges between a simple init-n workflow up to something that your corporate is running to gather data from Facebook or scrap LinkedIn or do some more action. But to keep it simple, and we can use this as something that we will build on as we move forward, an agent is some piece of software that lives in an environment or interacts with an environment. It can read the state of this environment or part of the state of this environment, and it can take actions and receive some feedback. This feedback can be manual, so users telling the agents doing good or bad, or it can be a mathematical equation, it can be something collected and fed again to the agent, and so on. And this is basically what we will call the components of the agent. The definition, we'll find many definitions, but let's stick to this idea because we will build over it as we move forward. As an idea, our agent is a worker that can perceive, it can somehow read the environment around it. This environment can range from text documents, videos, your UI screen on your phone or laptop, and so on. It can reason somehow and make an action based on this reasoning. So the reward can be human feedback, predefined rules, or reinforcement learning policies. The action can be anything from making the robotic arm move, doing an action on your computer, and so on. And the state can be the workflow steps. Let's say you're doing any workflow automation or so, up to something about a real environment with sensors. As a general idea, for the past 13 years, this will also be a problem if you're trying to research about it. What's called an agent was a reinforcement learning agent for 13 years, like from between 2010 to 2023. Everyone was doing OpenAI Gym and all of this, and an agent was a reinforcement learning agent specifically. Anything related to what we do today was either called computer vision with something around it, or NLP with something around it. But today they're all somehow converging, and this is all called AI agents. But the name or the idea is actually older. People have been trying to build this since Alan Turing, and we're still failing, so we will see. Also as an idea, and that's why we are talking about the definition, and this idea or the vagueness of the definition will help us as we move forward. All of these technically are agents because the initial definition of an agent was a computer program. The idea of a computer program was an agent. So not using any AI, but using some tools. These tools can be manually receiving data, doing actions on them, is an agent, but it's like level 0 agent. Once you have somehow rule-based AI, so you can have a small decision tree or random forest or so, it's still called an agent, but it's like level 1. You move a little bit more, and then you have reasoning and decision-making, so the agent is not only perceiving. For example, if you have level 1 agent would be a computer vision algorithm that detects cars in the street, but a level 2 agent would be another one that decides that the number of cars is a lot, so it's time to make the traffic light red or green or so on, or adjust the timer. This is the difference between like level 1 and 2. Level 3, as we move forward, is the ability to remember. So the agent is not only turning the traffic light, but it can remember what was the trend of the traffic light, what was the trend of the traffic across the week or month or so on. So it adapts. So if it's Wednesday, 6 p.m., it's rush hour, it adjusts everything. If it's 8 a.m. Sunday, it does something different, and so on. Level 4, which we call now today agents, is the LLM-based agents. They have the tools, they have the action, they have everything, but they have some degree of autonomous learning, which is not similar to what people called learning 3 or 4 years ago, and also some kind of generalization, which is not exactly what people called generalization 3 or 4 years ago. But this is what people call things now. And we will try to clarify them as we go forward. Level 5, which people are trying to build now, and to some degree there are agents doing this, by adding personality. So you're not only building an agent, but you're building an opinionated agent. Instead of building deep research, you have deep research which has my character. So it can have some kind of bias, intentional bias, and some kind of collaborative behavior. So you have multiple agents. They're to some degree autonomous in their communication with each other, or maybe connected to one central agent, connecting or coordinating how they work together. Generally, to go from level 0 to level 2, it took us 50 years, and it took us only 3 years to go from level 3 to level 5. This is how fast things are going. Until 3 or 4 years ago, the maximum you can do is making some robot arm or NLP algorithm or so with some memory with it, some reasoning, and you stop here. You cannot actually have some personalization. You cannot have autonomous learning feedback, or you can't have multiple of these agents working together in an autonomous way. Of course, there are many cases, especially in robotics, where people built multiple robotic swarms, and there is swarm intelligence, the old name before it was called multi-agents, but it wasn't to the degree that you have now, when you can, on your laptop, build 7 agents doing your work for you. So things are moving fast, and yeah. So trying to define our agent, we will be moving now between 2 states, like for the rest of the presentation. The first, we will be covering what probably most of you have an idea of, which is building an agent prototype. Probably you saw it in some video, you tried it by your hand and so. And then we will try to figure out why does this fall short when you try to take it to production. So if you're trying to take this, build it for your company, build it for an actual startup or so on, why does this prototyping doesn't actually work? Or what are the problems going with it? So usually our agent, whether it's from the old age, the reinforcement learning one or the current, you have some tools which you have access to. Before it was some sensors or so. Now there are some functions which you can call or APIs and so on. You have your memory, short term and long term. We'll discuss this more as we move forward. You have your planning algorithms. They differ in name. The planning can be even hard-coded. So you have a hard-coded sequence or so that you go through. And you have the actions that you take. The actions, at the beginning, when AI agents became a term, was only doing text stuff or sending API requests, but now the AI agents can do actions on your screen, they can send emails, they can interact with external programs. So actions are not only limited to producing text or producing the plan, you can do many things with it. And in reality, it looks somehow like this. So you have your reasoning model, this is your LLM API, which you call, or your local LLM if you want. You have some kind of decision procedure, which is your prompt, or the rules plus your prompt. You have many types of memories. So you have the procedural memory, which is your context. You have the semantic memory, which is your vector database. And you have something bigger, not many people use it, but it's usable, which is the episodal memory, where you can have not only different chats or different users, but the overall memory of the system. Similar to how you can write a prompt to ChatGPT, roast me, based on our conversations, and this scans 2 years of conversation and write something about you. This is more of an episodal memory. On the other side, you have the observation part, which can be, as I said, not only the text part, but now you can give a screenshot from your screen and ask Cursor to write the code for this front end, something like that. And on the other side, this is where most people are trapped or looking for, which is how we will make our agent better, like in performance. So how it will work better, how it will do or execute the prompts better, adhere to what we want to say, and so on. And yeah. So the problem with this, like going from this part to here, is things get really, really messy very fast once you try to apply it to real environments. Some parts of the real environments, you're dealing with the maps. You're dealing with chat, but with different languages. You're dealing with your UI. You're dealing with APIs from different providers. Some of them are limited. Some of them have rate limits or not. And on the other side, you have many environments that you can read and write to. So some people, for their data, it will be better to work on a knowledge graph. For other people, it will be a very old enterprise with only PDF files. For other people, they have very structured, very big data warehouses that you need to figure out how to access. And over all of this, you have corporate policies, which you need to figure out how your agent will work around. So usually, if you want to build an agent, your normal agent, you choose a model, any model you like. It can be local, it can be with an API, it can be hosted somewhere, it's okay. You choose some vector database and then embed a model for your memory. Some people do it even locally in SQLite with some vector database, a vector layer over it. You have some function calling. So usually most models now support function calling out of the box. So you have like your functions or APIs and so attached to the model in your prompt, and then you have some agentic blending algorithm like React or Rewo or so, which you can use to attach all of these together and start having your actions. This is usually what you do, or what you think about, like what will I choose for making my model, and then you choose one of the frameworks to build it. You can use a code-based one, like LangGraph, semantic kernel, small agents, which was released very recently. Or you can use a no-code one, which is now very famous. People using like Langflow, which is my favorite, or initn, which now you'll find many LinkedIn posts and GitHub repos about initn as one of the ways to build your agents. Once you reach here, you have your framework, which will give you some structures you can work with. You have your model, you have everything. You start writing your prompts, you start adding your data. Things are going well, and you have your agent. This is one initn agent making a call center, like simulating a call center. Going from this, you may want to build a multi-agent. So now you want to have one agent for maps, one agent for replying to your customers, one agent, let's say, doing something with internal team. So you choose one of the multi-agent frameworks. Like you go from semantic kernel or LangGraph, which support also multi-agent, but let's say you will use one of these. So you use Crow AI, which is the most famous Microsoft AutoGen or the recently released ADK by Google. And then you start thinking about the topology of these agents. How will they communicate together? Will it be one orchestrator communicating to many agents? Will they be interacting in a mesh way so everyone can talk to everyone? Will you go back to your networks course and start thinking about bus topology and rank topology and so on? You have to think about one way of how they will take roles basically together. And then you have something like this. It's like a report retriever in a hospital. You have the radiologist, you have the reviewer, and then you have the user putting the report. You get out of this something. So now we have multiple small AI agents working together. And these AI agents can communicate in this topology that we agree on. Like these two can communicate together, but only like the report and the report retriever and the radiologist can communicate together. The user can communicate with both, but not with the third. This is how we design your topology, how you want your topology to look like. And then that's all good. Until this point, you can easily do it in a weekend. Like for a basic agent, you can build everything, assuming you have some clean data you can start with, some credit on AWS or so. And you show it to people, your company board, you get some funding, but this point is the maximum you can get without going forward, like without taking it to actual users. This usually either runs on your laptop, runs on an EC2 machine with not much things around it. Probably you're using a free tier or not very high tier of an LLM model, and you think that it's not bad, but this stops at being an R&D project. At this point, you have a proof of concept, which is good, we can work with, but then you have a lot of real-world problems, which we'll be talking about in detail. So once you start taking your agent from the previous part, like I built my agent on my machine, I want to put it to production, you face at least 20 problems. These problems I collected just from my discussions with my colleagues, some of the keywords we discussed. There are even more, so this is not the limited one. But generally, you have to deal with 4 dimensions moving forward with this. You have to deal with the infrastructure and deployment. Now that you have many software pieces, sometimes they're not written in the same framework for any reason. You have to deal with this. You have to deal with the system architecture. Now we are talking about a real software project. Maybe all these agents are Docker images. They have some kind of communication between each other and so on. You have to deal with the quality assurance of the models. These are working together. It's very hard, as we will discuss, to actually control the output of the model, and very hard to evaluate the output of the model, especially if you're doing something that's multi-step. And if you're working in something that's not a startup, or even some startups, you have to deal with the compliance and security and so on. So we will be covering in the next few slides these in more detail. I tried to fast forward the previous part so we can talk about these. And I hope by the end that we reach a point where we are able to figure out a rule of thumb. And this rule of thumb is when to build an agent or not, where you can resort to something easier and so on. So starting by the first step, infrastructure and deployment. You usually have 6 main problems, which many problems can come around from. The first is the cost. And by cost, we have a very big problem. It's very hard to define and track the actual cost of the LLM system, because people can throw documents at your system from 1 to 500 pages. People can use different documents with different token sizes. So it's very hard to have, to tell your management, let's say, okay, this system will cost $200 per month, similar to other older AI systems. There is some variability, so you have to give them some upper and lower bound to this. The other problem is the cost tracking. Previously, and let's say you're not in an ideal case where your company is a single vendor, you have your model, Gemini with Google, but your infrastructure is in AWS. For some reason, your vector database is hosted somewhere else. Now you have to track your cost across 3 or 4 or 5 platforms. Later, you will add some prompt versioning tool. Later, you will add some external APIs, which are the tools that your agent is using. And you have to track the cost of all of these. Again, for the demo, you can easily see all the dashboards. You say, okay, this system is costing $20 per day. But if you move to a more isolated deployment, so let's say your company is dealing with 5 departments, you're deploying them to all of them. Now we have to start implementing some budgeting rules over this. On the other side, you have should we go cloud or not? So one big consideration for many companies, universities, government, factories, they can go cloud, either for legal reasons, like compliance reasons, or for security and so on. So going cloud is cheaper because you start with 0 and you start counting, or going on-premise, you have to pay upfront. So we need to get 20 GPUs. This is costing $40,000, $50,000. And you have to convince people to pay this upfront in order to invest in your system. Another thing is the deployment and model serving, not only for the models, which maybe at the end will be APIs, but the modules of the system. Now you have your vector database, which is one more database in your system other than the original one. You have the Docker images for these agents, and you have everything related to them as an infrastructure. Also, the resource scheduling and scaling. This is not exactly for the LLMs part, but if you're deploying on-prem and you have your machines running, even if they're running on your machines, once you start doing something a little bit on scale, you have 20 or 30, 40, 90 cards, let's say, they consume electricity. And now your company will be calculating this electricity, because now it's not a small amount of electricity. So even if your system is idle, you need to figure out and build a layer over this to descale, scale down or up based on the usage, these GPUs. If you're doing it, again, on your laptop or even doing cloud, you don't pay for the electricity. Usually you don't count for the electricity. But once you have a system, and this is one case, we had a small system in a factory with 5, 6 users, but to achieve what they wanted to achieve, they needed 5 cards. It was 4070. And the bill of this varied significantly when we cut down the number of GPUs based on automated scheduler. So we can cut off the power over some of them and run the others based on the load. One other big problem, which again, it may appear when you're prototyping or not, is the dependency management. Dependency management here is two levels. The first is the level of the libraries you're using. Now, you're not using one framework. Usually, your framework depends on another framework, and they all depend on OpenAI at the end. You need to figure out this. And you have also the problem of managing the dependencies of the different pieces you're working with. Sometimes, especially that everything is moving fast, Quadrant will release an update to their database that breaks anything that works with Gemini for some reason, and it happened. So you need to figure out this, and sometimes this will make you add more layers to your system to figure out this part. The hardware compatibility, on the other side, with the biggest problem is you cannot use anything realistically outside NVIDIA. So you have to figure out your GPUs and so with this constraint, and of course, anything related to the versioning and fallbacks and so on, especially in multi-agent systems when you have like 5 or 6 software tools talking to each other, and for some reason you update this but not that, and you need to figure out how they will be versioned and communicated with each other. On the other side, for the system architecture, and we can start actually with the use case directly. Let's say you're building a multi-agent system for a bank or so, and these systems are very highly fragmented. You have the new teams using Notion and so on, the old teams using SharePoint or maybe something older or less common. And you need to figure out how all of these types of data will work together, how all of these APIs and so will work together. One department maybe using SAP, another department are using a custom CRM system developed 20 years ago, and so on. So you need to figure out how to build the unified data layer for all of this. How will you access all of this data in some unified fashion? You will need to figure out how we will work with the different APIs. Now it's easier with MCP, but you still need to figure out how we will handle all of these MCP servers, which is another problem. You need to figure out how to chain and orchestrate these agents, especially when it's organization level. Maybe you have some agent for a finance team and some agent for payroll team or HR team, and they need to communicate together. So you need to figure out how these agents will be communicating and taking actions based on each other. And yes, handling the cross-department agents and customizing the interface for everyone. Usually, people, because of ChatGPT and Gemini, when you start building an agent for them, they expect a chat interface, and they can throw anything at the chat interface, and they expect it to work. Usually, when you're building your agent, you customize it for the prompt or for the set of prompts you're working with, and then the user will start doing something, anything, like they will upload a random document. You need to handle and figure out how you will handle these documents before they reach your system and contribute to the cost of running and like the document and so on. For example, you uploaded an invalid document. I don't know, the system is for finance and someone uploaded an HR document. You have to figure out how this document will be blocked before going through your RAG agent and all the embedding and so on, and costing you like $10 for this simple mistake, which is not a mistake, it's just the user being a user on the other side. Other problems that we need to deal with are the different communication protocols that everyone's talking with, where you treat the multi-agent system as a microservice system. And you need to choose how the multi-agent system will be talking to the world, how the agents will be talking to each other. You have the problems with the state management, especially cross-department, where everyone is dealing with something different. You have also the problems of the failure recovery. When do you tell the user it's failed? When or how do you retry? And so on. And which is, for me, is one of the biggest problems that we face every day is the agent identity and the session handling. When you're working with normal APIs or even normal LLM systems, you're usually either stateless, so you do REST API back and forth, or you have some kind of a normal session, with any token, and you handle it. But the same agent can be deployed at different departments in the same company, or maybe for different use cases at the same department. And you have to figure out how to identify the agents, how they act differently based on the different users. It can be like by team level, by department level, or even by user level. So if user X, which is an admin, which is the finance manager, is accessing, they should be interact through the same through the same chat interface in a different way that the junior accountant in the same interface is dealing with. So this needs somehow a kind of identity and access management on the agent level, not only by a token or so, but you need to figure it out on the data level, on the data access level, in the vector database, and so on. Moving forward, for me, this is the most interesting and also the most hard part moving forward is the quality assurance. So before LLMs in general, even people who worked with NLP before 2020 maybe, it was very easy to evaluate your NLP systems. You have some kind of a metric that we agree on, cosine similarity or anything, and then you say, okay, my system is working by X%. Or you have some like RMSE or so, where you can translate these into a percentage, and you go to the management and tell them, I have a percentage. This system is 20, 80, 90% accurate, or it's not working, and so on. But this was doable because the input and the output was somehow deterministic. You have a sentence in, you have some labels out, or even another sentence out, and it was easy to measure it. But now we have a free-form input and a free-form output. It's very hard to evaluate deterministically, like to write a test suite for your system and expect the LLM every time to perform the same. One of the biggest problems here, not even on the agent level, is running the same LLM on the same prompt multiple times will somehow get like minimally variable outputs. So you cannot exactly replicate the same output every time. And this contributes to some degree of error. So it will be like 0.001. But imagine you're having an agentic system with 10 agents. Each one of them is doing this. And you do your demo, everything is working well. Your manager comes, he tries the same system, and it's producing slightly different thing. This is one of the biggest problems. For this, we need to figure out observability, which has two levels. You have the LLM observability, so figuring out what are the tokens in and out, what are the prompts being added, feedback and everything. And usually this is done with Langsmith as one of the things. And you have the observability on the hardware level and the cost level. You need to figure out, okay, for some reason, this user uploaded a document which has, which doesn't cross our token size, but our file size limit, but the token size limit, and it contributed to a very high cost. You need to be able to trace up to this exact prompt and this exact document that was uploaded or prompt interacted and so on. The other problem is the evaluation. So it's very hard to get a generic evaluation for your system. Usually before LLMs, you can easily have some like validation data set, test data set, you run them. No matter how much you run them, the percentage is almost the same or somehow the same. And then you start going to LLMs. The first problem is you cannot build a universal data set, or you cannot build a universal evaluation data set. You have to figure it out, not per use case, but per department, literally. So if you have your finance department dealing with something, you have to make a benchmark exactly for them. And you need to figure out a metric, because the LLM metrics, like there are many things like faithfulness and so on, these doesn't make sense to users. They are scientifically correct and 100%, no problem with them. But when you try to communicate these to users, normal users, business users, they feel nothing. Like what is faithfulness? What is confusion? It doesn't mean anything. So you need to invent the benchmark, and you need to translate whatever your deep eval or anything is saying into something that the users can understand from their side, because even with older AI systems, they have this accuracy 89%. You have to figure out all of this to be into a number, which is a very hard, this is for me currently the hardest problem in evaluation in general. System latency and performance bottlenecks happen, and you have to track them in your QA cycle. And one problem with them is it's not always predictable. One known problem about this, people using Cursor, specifically with Claude models, complaining that sometimes the model is dumber, or sometimes the model behaves much slower. Because this time is active in the US, so it's like 1 hour from now or so, and users in the US are starting to access it with very huge numbers. So in every other region, it becomes slower, or it becomes hallucinating more. But try to use the same model our time, maybe like 6 or 7 a.m., it's performing much better, or it's faster. So this is something that you cannot predict, and also Claude didn't confirm or not, but people noticed this as one of the things that you have to deal with. And for me, the final part, which is not the hardest, not the best, or the easiest, but the most boring, but also this is the most important step to actually taking your system to production. For developers, it's very boring. You have to deal with, but without it, your system probably will not see light. It will be good at your GitHub repo or so, which is compliance, security, and all of this. So first level is security and access control, which now you have to manage it not only at the system level, not only at the user authentication and authorization and so, but you have to manage it on the all data levels, which can be cross-department, which can be departments that should not see each other's documents for any reason. So not everyone should see finance documents, but finance can see somehow everyone. You need to figure out how your system will manage these. Sometimes, and it's very common because agents are designed to replicate humans, so people building the agents are trying to replicate their company hierarchies. So this agent replicating this department is following the same access control levels and so, designed by the company itself. So this is your organization structure, basically. And you have to figure it out, not with the normal like admin, manager, normal user. Now you have like the vice, deputy something of department being able to report to someone else. Complexity. Data privacy and compliance, it gets very complex because it has multiple levels. Not only for, you have your company data or your department data, and then you have your local and national data laws. For example, in most countries, you shouldn't take telecom data outside of the country. You cannot host it outside of the country. So let's say we're building something here. There is no region in Yerevan for AWS. You cannot use any model from Bedrock because you cannot take the telecom data outside of Yerevan or outside of Armenia. And then you have the other level, which is the regional data policies. So everyone now, even if you're not exactly selling in the EU, you have to have some degree of compliance with the EU AI Act or GDPR and so on. Again, even if you're not, but it will make you not sell because even people in regions which don't exactly follow these laws will look at them as a standard. So if you're not following the GDPR now, like in a place that doesn't follow GDPR and someone like feels you don't follow it, they will not use your tool basically. And the third problem, which is still an active area of research, is the prompt management and injection in general. So there are different philosophies here. Some people are treating prompts as code. So they store them in GitHub, they version them in GitHub, they do everything, they even write comments in the prompts or like next to the prompts. Some people are treating prompts as data. So they work with them as data sets with everything related to them. Some people are treating them as second-class citizens because anyway, these prompts should be eventually some rules like the DSPY library and so on. They don't treat prompts as prompts, but they work with them in different way. And all of this leads to not enough research being in the injection part. Like how can I, for example, leak your system prompt? Even till today, with all the big names, open source and closed source, it's not very, very hard. Like it's non-trivial, but it's not impossible to leak the system prompt of Cursor or Claude or OpenAI. It happened many times. Whatever you're trying to put to prevent this, you can leak it. And it may not be a problem if you're running Cursor or Claude, but if your system prompt in your company or your organization is having some secret rules or rules that cannot be leaked, this is how it takes a decision. It shouldn't be leaked to like employees who shouldn't have access to this information. But your prompt, because the prompt is your agent, which is trying to take this action, have these rules, and people will try to somehow jailbreak it and get this out of it. This area is still active research. People try to do it with prompts. People try to do it with guardrails, like Nemo guardrails and so on. But there is no one killer option for it. You will still have some kind of prompt. If someone in your company or outside wants to inject your system or wants to like either inject malicious information into your prompt or retrieve back your system prompt, they will be able to do it if they have enough time. And when you try to build all of these, so like you have all of these 4 dimensions, when you start thinking about them, you start thinking about like more about software engineering. You're thinking about DevOps, you're thinking about backend engineering. We didn't mention anything related to the UI and how you handle all of this with the UI, with the streaming and everything. You think about security, and the least thing you think about is the AI part. So you assume that there is a working prompt somewhere, with a working model somewhere, with some tool somewhere, but taking them to your users on the other side turns into a software engineering problem. Now you need to get your backend developer or your DevOps engineer to figure out how we will do all of this. You need your security or DBO or so on to be involved here to make sure, can we use OpenAI? And the most common question maybe in February, so can we use DeepSeek? Can we use a host, like a self-hosted version of DeepSeek? And all of these similar questions, which they are asked. And then you end with something like this. Like this is somehow one of the systems. Like you will end with something that looks like a system that you develop when you're doing your system design for a back-end system or like a normal microservice system. You have some front-end application doing everything related to the tokens and so on. You have all the microservices work, the Terraform code, and so on. You're using or calling OpenAI, so you have the serverless functions on this side. You have the model deployment and management, whether you are deploying locally or if you're deploying with an API, the configuration is the model that you have to manage here. You have to save, you have to take care of, and so on. And then you have your model store, which handles all of this, and your feature store. And now your feature store is your vector database, or databases, depend on which type of vectors you want to save. And with all of this, you have your data pipelines, your data source systems, which is the most messy part, and your hybrid cloud infrastructure managing all of this. Because it looks neat, but this lives among like 20 APIs and 2 or 3 cloud providers to make it alive. When you go forward from this, like this is now not implemented. So this is like the conceptual layer that you will have in your system. When you move forward with it, somehow it looks like this. So now this is a more framework-ish representation of it. You have here your user interface, some UI features. So you have the chat. You have to implement the chat. Usually you can use like a ready solution for this. You have the project management and all the data rules related to how you manage these files and how you reflect from, like previously you used only to deal with a database and some blob storage, S3 or so. Now you have to deal with the database, the blob storage, and the vector database. And you need to make sure all the 3 are linked together, and you need to make sure all the 3 are making sense together. And then like all the data selections you go here, you have, like they call it here marketplace, but this is where you have your agents, how you can control and deal with these agents. When you build a system where it's now turning a platform, like when you build a system for your company, which has 20 or 30 or 40 agents with one chat interface, there must be a way for the agent discovery. So I wrote something, the user is using ChatGPT or using one of these systems. They don't want to click on a button like finance agent. They want to say, I want to do the calculation of the company earnings last 2 years. You should figure out that you need this agent and call it from here, and then you go to the whole agent part with the rack side, with the agentic like orchestration part, and then you have to build usually yourself the responsible AI layer, because even when models have content moderation, your company or your organization have another level of moderation. Maybe for people names, maybe for numbers, maybe for like showing or limiting some data for users. And then you have to figure out how you will get to your LLMs and finally everything related to the data on the side. So one part here is a data engineering problem. You have to figure out your data and everything. One part you're dealing with front end, back end, and so on. We have here also all the LLM ops, which most people, at least for the start, use Langsmith as a common like a solution covering everything you need. But as you move forward, there are some things, especially organization level, when you are doing it, you cannot do it exactly with Langsmith. So you have to start developing your many solutions for hosting them. And you have only this like small part, which is the actual AI here. It's not a small part. It's a small part relatively to what you need to do, but it's not a non-trivial part. Anyway, like without any of these, without the LLM and agent part, you don't need any of this. But the idea is we need to do much more effort moving from like these 2 or 3 blocks to having your actual system. Because again, you can use Streamlit or Chainlit or something similar and have the UI and have the project management out of the box, but you cannot show this to your normal users. So based on this, you need to actually evaluate if you need an agent or not. Sometimes you may not need an agent, or you may not need multiple agents, like multi-agent system or so on. So, when to build an agent? Three main ideas. If you have complex decision making with your system, when you have difficult to maintain rules, or not actually rules, like you don't have a structured rule somehow, and when you have a heavy reliance on unstructured data. Basically, when you're dealing with your management. So if you're dealing with a management layer like C-level or board level in any company, they usually communicate in emails, PDF files, doc files, BBTs, like slides everywhere. So you need, for this to build an agent, usually the business rules are moving per quarter, per month, per year. They're just not static. The business rules and the requests needed from the business is not something static. They change as everything changes. And then the decision making, which is not only fuzzy, like deterministic, but also complex. You cannot exactly have pattern matching, do this and then this and that. You will get a decision. Usually you have multiple branches with different biases or different ideas that you need to cover. So this is the three main reasons. If you check all the three, you need to build an agent. If you check two of the three, you need to figure out if you really need an agent or not. And there are two lower levels, or like less complex levels of agents also that you can build. Now they're called an automation or a rule-based automation and a workflow. A workflow is anything that you can build deterministically. If your rules are linear, you have a very, like, for example, you are doing a support agent for your website. And assuming this website is an hotel booking, like something linear. To build this, you can have a workflow. The workflow is one step, two step, retrieve from the data, answer the user, do this to book the room, do this to book that. This doesn't really need you to build an agent. And by building the workflow, whether it's visually, like with n like this, or by using any other tool or by code, you have control over what happens. And if you want to add an AI component, it will be just an LLM call. This LLM call going to your RAG, answering a question about the price of the hotel room tomorrow or something. You don't need something more complex than this. On the other side, if you are doing something that's very deterministic, rule-based, you don't need an AI for. You should do a workflow, like an automation workflow, or an automation, like rule-based automation. They call it now automation. This is a set of rules. They can be a Python script. They can be, again, on UiPath or N8N or any of these tools. And everything here is deterministic. You usually don't have an AI component. You usually don't have any, like for example, every month you need to send an invoice to X client at X date. This is something that will repeat every month. You don't need AI for. But you can implement it with AI. You can implement an AI agent calling tools and calling to your ERB, getting the invoice. You can do it, but you shouldn't do it. Same here. You can build, and by the way, there are many, probably you saw it. Like, there are many Medium tutorials and similar things telling you building your multi-agent chatbot system. Usually, you don't need a multi-agent AI system, chatbot system. So, to try to finalize what we said in this few past minutes, we try to make a rule of thumb when to build an AI multi-agent system, when to build a single agent system, when to use only an LLM workflow, and when to just write a script for it, or like do a normal automation. If you have a very complex, open-ended, multi-step, multi-actor, non-linear problem, you should make a multi-agent system for. This is something, for example, you're trying to simulate your marketing department. You need to have some kind of a multi-agent system for this. If you are trying, like MetaGPT and Cursor and so, to build a software team, someone doing the PR review, someone publishing the code, you need to build, again, a multi-agent system, trying to decompose everything. You can build a single agent, not multiple ones, if you have a complex nonlinear system and so, but it's one actor problem. So let's say you're building a deep research agent. I want to research companies' financial performance over 1 or 2 years. This is one actor. It's a complex problem. It's nonlinear. You have to do and go in different ways. It's open-ended. You can't actually have the same research produced twice. But somehow it's one actor, the deep research agent doing something. You will find people in different approaches, which is not wrong, but it's not optimal. building the same deep research with multiple agents. And they have like a reviewer agent, a writer agent, a researcher agent, and there are like 4 agents, which is good, again, for an open source project. Try to take this to production, and you will suffer a lot with the cost of running this. Finally, to build an LLM workflow, so this is anything you build with LangChain, Llama Index, and similar things. If you are solving a non-deterministic problem, but it's linear, it's multi-step, and the outputs can be deterministic. So question answering is one of them. Anything related to summarization and similar ideas. You don't need an agent or multi-agent for this. Usually, if you're doing it for your company, like let's say you are a legal company doing legal documents summarization, you can use an LLM workflow for this. You don't need to make an agentic system for all of it. If it's nothing of these, so if you have a deterministic problem, which is linear, which has one actor or so, and the output is deterministic, you just build an automation workflow for it. Just a normal, can be a Python script, it can be on any like N8N or other UI tool to build your whole system inside. So this is for me, and this is like, I devised this based on my small observation, is a rule of thumb. Sometimes you may need to change it. Probably you're building something here that's a little bit too complex. You need to divide it to 2 or 3 agents. It's okay. Sometimes you're building a deterministic automation, but it's too complex. You try to simplify it by handing part of this complexity to the LLM. Also, this is okay. Sometimes you may need a multi-agent system for smaller problems for many reasons. One of them can be cost, by the way, even if it's paradoxical a little bit. But if you choose the right models, you can use a multi-agent system and be cheaper than using a single one. But again, it requires a different setup in your hardware and different setup of how you build your system as an idea. And yeah, just to start the question and discussion, do you agree that based on what we discussed, building or scaling agents is 80% software engineering, 20% AI engineering? Raise your hand if you do. Sure.
Hey, I'm Narek.
Can you raise your voice a little bit?
Sorry, what?
Can you raise your voice a little bit?
Yeah, hey, I'm Narek. Up to recently, I was a PM at AWS working on Aurora and DocumentDB. My question is, most of the points you brought up about security or role-based access, let's say, are back. How is that different from databases? Can we apply the same approach the way we architect a database to LLM projects? And also, what is the parallel with, let's say, having microservices compared to, let's say, MCP or architecting like multi-agent software?
Okay, these are 2 good questions. The first one, you can and you should use already things that we have in database. For example, if we're in AWS, we have already good backs for identity and access management. You should use them. The only hard part while dealing with agents is sometimes you need to reflect your organization structure on them. But you should not reinvent it again. And the way agents are built now, somehow everyone's trying to integrate with existing authentication. Which brings us to the second part. MCP and like Crow AI and all of these technologies are replicating microservices already. So now if you are building a multi-agent system, it will be a few Docker images, you build some Helm chart for them, you have Terraform code, it lives as some code in a Docker image or a Kubernetes cluster somewhere, and you try to abstract the idea that you are calling an external LLM. You add more complexity if you have your LLM self-hosted, because it's part of the cluster now, but 100% it follows the same idea. And actually the good differentiator between, I don't know, AI 4 or 5 years ago and now, 4 or 5 years ago, you needed different setups to get your models and so to work. Currently, you can just treat it as your normal system design problem. So you have your system design, you have everything normally, and you have to account for the external services you're calling, which are the vector database or the LLM model or so on. And your agentic workflow, like the lang graph or anything, is just another back-end service. Even MCP is built with built-in authentication support, with built-in support for HTTP and HTTPS and so on. So everyone is moving to the direction to not try to build everything for everything again.
And from your experience, what you see, is there an agent that, let's say, where I can plug it to my data warehouse and somehow, based on prompts, it can understand the which data is more important to a certain department? Let's say I have a data warehouse, maybe for finance team. Is there an agent that can automatically grab finance-related information?
Many people claim to build this, and they are building this, but the problem is figuring out the rules that you will apply to the agent to understand your data sources. So you have many things. One of them is AutoGen, their first agent they developed. You have also Jules that was released, I guess, by Google a few days ago or so. They all claim to do this, which they do on a trivial case. Once you go to a real department with messy documents, with like usually your finance department doesn't have everything in Excel. They have it in emails, and they have it in Excel, and they have it in documents. So the hard part here is not the agent itself being able to figure out, but how you will make it figure out your data schema. Even if it's unstructured, where to look for. Like usually, this is the hard part, data discovery around the system, especially for departments or people not using some kind of an Excel/SQL/ like a database thing.
Say my data is structured, it's a data warehouse.
Yeah, if it's a data warehouse, you can easily apply this to it. There are many agents already. I can get you some of these names. But if it's not a structured, it becomes a harder problem because you have to discover where the data is and how it looks like.
Gotcha. Thank you.
Okay. Yeah, sure.
One question. My question about no-code, low-code, and coding platforms.
Yeah.
What are the best no-code platforms for beginners starting from scratch? I mean, is it Zapier, Replit, or anything, or something else? And what are the pros and cons for no-code and coding platforms?
Okay, so for the best platform, it depends on what you are trying to do. If you are building an application that later will be coded, or like people will continue coding on, Cursor, Replit, and so are very good because they produce actual code, which later you export, you give it to your developers, or you continue developing on, and so on. But if you're building a business automation in general, or you want to prototype very fast with an idea, N8N or Langflow will be better because they're just like you drag and drop. If you're coming from an engineering background using Simulink or so, this is natural to you. Like you will be easily using these because you already use Simulink or LabVIEW or so on. The pros and cons, I did both. I developed both. Like I built no-code tools even. It comes to how much degree of customizability you are looking for. You can do everything to a degree on the N8N, but then you will have a logic spaghetti where you have like all these nodes connecting and so. So it becomes more cleaner to do it in code or with some coding platform. On the other side, no code is better if you have not only clear requirements, but you're not doing much customization. So if you're dealing with the normal databases, the normal business tools like SAP, Oracle, and so, if you're dealing with the normal APIs, you can just use one of these. It will save you the cost, like the cost of everything, development, hosting. They have a predictable hosting plans. So if you use N8N, you host with them. They have host, like you can easily say my usage is like this. I take this package and it will be good. On the other side, it can be not as predictable. You can't say like I will pay X per month to get it. So it's better this way. So for me, it boils down to how much customizability I'm looking for, and for the problem, which part I'm comfortable with more. I would be more comfortable, let's say, building by Replit or from scratch by hand an automation with Python, if I'm doing something with more APIs. And so if I'm having a flow chart from another department and I want to implement this flow chart, I would copy the flow chart to N8N because I can somehow get it like almost one-to-one correspondence between the flow chart and what I want.
Hey, thanks for the presentation. Can you go back for 4 slides?
Here?
Yeah, this one. No, this one, yeah. So if we take an example of like OpenAI's agent that does grocery shopping for you in Instacart.
Yeah.
Can you explain why it's an agent and not just a like complex workflow?
For two reasons. You can classify it as this, but let's say it's an agent. I would say it's an agent because it deals with an undeterministic environment. The grocery shopping, you can do it in multiple websites, not the same website, or multiple applications. You can have different items, and you need to figure out if there is no lettuce, bring carrots. This idea you cannot figure out using a normal workflow. So the ability to take the decisions or optimize the final result, if you have a workflow, it will tell you like, get all of these and mark what's not available as not available. The ability to scan what's available and search for alternatives and pick a good alternative, or maybe adapting, okay, there is a discount or something, or this can be a better brand of something. You cannot make a workflow to tell you, okay, choose this brand or this one. You need to make an agent decide it. Because in real time, it will compare between the brands, it will make a decision and choose the most suitable brand. This is what makes it an agent, not a workflow. A workflow, even on the screen or anything, would be like a scribing agent or an automation with Selenium or so. I would make it go, click on that, click on, like, and I know the SKU of all the items I want, put them in the cart, check out, put my credit card, and get it out.
This is actually what the agent does, right?
Yeah.
Now.
Now it does like this, but if you, like this is the OpenAI one, but there are other agents built like this, which can do the shopping for you on Amazon or so, with much more different variability in the decisions and so.
Okay, thanks.
Thank you. If you have more questions, you can ask after as we get toward this. Thank you.